So, on the calculator, there are several things you need to be able to do. Okay, let's just kind of list them out. One, you should know how to find zeros. Do you guys know what zeros mean? Somebody said it. What was it? X-intercepts. So zeros is just a fancier, well, depending on the context, it's just a different way of saying finding x-intercepts. Okay, so you just kind of need to remember that it's the same thing. You should also be able to find maximums, minimums, intersections, and then you should also be able to adjust your window, otherwise called a viewing rectangle. I think that's the way the book refers to it. So that if you don't have a nice picture on your graphing calculator, you can get a nice picture on your graphing calculator. Okay, so those are the four things that we're going to review. Let's just start with an example. Let's say we wanted to find the zeros of the equation y equals x squared minus 4x plus 2. Let's see, where should I put this so it's not hard to see? That works, I think. Okay. So, first, what do? Y equals, good. Type in the equation. Hopefully you know how to type it in. If not, ask. And the good news is, most of these skills that we listed earlier, if you go to the second trace button, you get to this menu that we call the calculate menu. And what do we see here? We see value, which we won't use too much. Zero, which is one of the things we want to talk about. Minimum, maximum, and intersect are all right here. Okay, so this, you go second, and then trace. Second trace. And that's your calculate menu. And all the options that we need to worry about are right here today. Okay, so first we said zeros, right? So let's go to option number 2. And this is probably not the greatest viewing screen, so let me go to zoom. And I'm going to start with the standard viewing screen, which is zoom number 6. So that puts everything back to normal. If you've ever had a hard time getting your window to be what it usually is, that's the fastest way to reset it, is to go zoom and then number 6. Okay. How many x-intercepts are there? There's one right there, one right there. So if I go to 0, now it says left bound. Okay, so what that means is if this is my x-intercept right here, the calculator wants you to highlight a point that's to the left of that x-intercept. Does that make sense? So I'm gonna hit enter because I'm already to the left of that. And now it says go to the right. So if I arrow over to the right, that seems far enough. Hit enter. And then now for the guess, I usually just put it pretty close to the x-intercept and hit enter a third time. And then it says right here, the 0, or the x-intercept, is about, let's write this down, 0.586. That's one of them. Go ahead and find the other one real quick. Let's see if you guys can do that. Anybody have it yet? Go ahead, Katie. 3 point. Have you hit enter a third time yet? Because I'm getting around that, but not 3.6. Let's try it. Second, calculate 0, enter on the left side, enter on the right. If you hit enter, did you get to the point where it said guess? If you hit enter after that, it tells you this is what I'm getting. Let me check something real quick.
That's not what you getting. Okay.
I think the first time you Okay. All right, so here's the nice part. This is a very fast way, 3.414, a very quick method to find x-intercepts approximately. Okay, but the calculator, your calculators anyway, will not tell you what the exact answers are. Okay, so actually let's go ahead and do that. They're not liars, they just... Okay, so to find exact answers. Because your calculators they don't really solve it algebraically when they do the graphs. They actually use the pixels and all that stuff on the screen, and they do a process where they keep zooming in until it's really, really, really close to 0. So it's not like algebraic. There are calculators that we call CAS calculators, which are computer algebra systems, that actually will do all that algebra for you, which is not allowed on the ACT, which is why we don't use them. But they're only like $20, $30 more than these. So when I was in high school, my calculus teacher said, if you're going to study any science or math, I recommend you get one of these calculators. And I said, all right. So I went to go buy one, saving up my money for my part-time job at the pizza place. Walked over. Actually, no, I think I drove over. Right before I went over to U of I, got my fancy calculator, went to my math classes, and almost all of them, guess what? No calculators were allowed on any quizzes or exams. I was like, oh, there goes $130. No, I actually ended up using it like on homework and stuff because I figured out how to use the algebra part on there, so I would check answers and stuff. So it helped me in that regard. I couldn't use it on the test, but it was nice. It was a nice resource to have, kind of like Edmodo for you guys. That was my Edmodo because we weren't told answers. Yeah, yours is free. Okay, to find exact answers, we're looking for an x-intercept. So a long time ago, you were hopefully taught that if you're finding an x-intercept, you have to plug something in. Yeah, good. Set y equal to 0. So if we set y equal to 0, we get 0 equals x squared minus 4x plus 2. And then now it's just a matter of solving this. This is a quadratic. We have it already set to 0, so that's good. What are the two methods we've talked about without a calculator? Factoring. Can we factor it? So quadratic formula. Let's see. X would equal. So 4, which is 16. Good.
Plus or minus 4.
It's just minus, right?
Oh, it's just
Minus 4 times
1 times 2.
1 times 2, a times c, all over 2 times a, which is 2 times 1. And now we just clean it up. 4 plus or minus 16 minus 8 is 8. What is root 8 when you reduce it? Good. And it looks like I can divide everything by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1, so it's just 2 plus or minus 1 root 2. Okay, and I'm willing to bet $1 million, if anybody wants to take me up on that, that these two are going to be approximately those decimal values. If anybody types them in and does not get those decimal values, I'll give you $1 million that I don't have. But maybe one day I will find you and say, oh, I owe you $1 million. Here you go. Okay. So exact answers have radicals, approximations. That's what the calculator's for. Are there any questions on that?
On the ACT,
Yep.
if they ask you for a y-intercept, put the one with decimals.
Well, it's all multiple choice, right? So the choice will be made for you. So if this was an ACT question and you saw find the zeros of some function and you're like, man, I don't remember how to do the algebra, but you know what? I can do the zeros in the calculator. You're going to get this, and I guarantee you're going to have options that look like this with radicals and stuff. Then you can just type them in and see, compare which ones are the same, and that'll be the way to do it. Okay? Speaking of intercepts, how do you find a y-intercept? What is 0? X is 0. Okay, so this one's easy. The original equation was right here. If I plug 0 in for x squared and negative 4x, I get 0 plus 0, or minus 0, but doesn't matter, plus 2. So the y-intercept here is 2. Okay? All right. Let's stay with the same problem. And let's find a max or min y value. So let's look back at the graph. Looking at the graph, do we have a maximum or a minimum? We have a minimum where? What is that called? Vertex. So you guys remember some stuff. That's good. Now, a couple units from now, we'll actually do this algebraically and get really, exact answers. For now, just doing it on the calculator is going to be fine. So, let's go to our favorite menu. Right? Everything we need to know for this unit is going to be right here. Which number?
3.
We said there was a minimum, so we're going to do 3. And now the calculator says, tell me a point that's to the left of the lowest point. So I should arrow over to the left of my minimum and hit enter. And then right bound, do the same thing. Arrow over so that you're to the right of the minimum. And now for your guess, you could hit enter again or get it somewhere close to that, but eventually you hit enter a third time and
I got 1.9999. Y equals negative.
okay, so now hold on a second. Let's answer the question first. The minimum is always the y value. Does everybody have negative 2?
Yes.
Okay. Now, depending on your calculator and which version you have and all that stuff, sometimes it'll round a little differently than others. So some people might have 1.9999999 and others might have 2.000001. Guess what? It's 2. Your calculator is just rounding because
Why is yours
I got lucky. However, whatever procedure it does or algorithm it does, it actually worked out, then it did get 2. So whenever you see that, you just need to remember that, okay? Let's see. Zeros, max and min. Let's talk about an intersection question. Find the intersection.
Is this all?
Yep. Of, let's say, y equals x minus 5 and y equals negative x squared plus 4. Do you guys want to try it real quick?
You just plug it in
Give you a minute. See if you can get them, and now I'll quickly go through it if you don't remember how to use your calculator for this. First step, if you forgot, is to put them into y1 and y2. So x minus 5 and then negative x squared plus 4. Graph. Looks like my window is pretty good. I can see that there's how many intersections? 2. Favorite menu? Go to second trace. Which option? 5. And now let's understand what the calculator wants us to do. It says, what's the first curve? Well, it's not really a curve, it's a line. Okay, but it means the same thing. All you have to do is hit enter, because up here it already tells you that y1 is highlighted. Okay, so after you hit enter, the calculator has registered that the y1 is one of the curves that you're trying to look at. And now it says, what's the second thing you're looking at? See how it already goes to y2? You just hit enter again then. So now it knows that it's looking at the parabola and the line, and this is exactly why the guess feature is here. There's 2 of them, right? So you want to help it out. Which one do we want to find first?
Well, you want to find the one lower.
Sure. It doesn't matter. Just pick one. But you got to get it over there so that it's reasonably close. Hit enter a third time, and then let's write it down. So approximately negative 3.54, and then negative 8. Are you guys all getting the same thing?
What you got?
Negative 8.54. Okay. And now for the second one, repeat the process. So second, calculate option number 5. And now hit enter twice. It registers that we're looking at the parabola and the line. And now when it says to guess where the intersection is, get it really close to the second one. Hit enter. And I'm getting about 2.54 and negative 2.45. Okay? Does that make sense? Okay? Real quickly before we finish up with windows, how do we find the exact intersections? So Ryan suggested maybe get x alone in one of them and then plug it in the other one. That works. What's another option? You can set them equal to each other, which is the same thing Ryan was saying, but you see how y is already alone? So we could just say, let's go to the second equation, and since I know y is equal to x minus 5, just plug it in. Does that make sense? And now how do we solve this equation? What kind of equation is this? Quadratic, yes. So what do we want it equal to? So I'll keep x squared positive, move it to the left. Subtract 4. Okay. What do we do at this point? Quadratic formula. Good. If you're okay with that, I'm going to not do the rest of the problem, but you guys get the idea, right? If you do the quadratic formula, you will get exact answers that will come out to approximately this for x. Okay? But once you have x, guess what you have to do? You got to go back and plug it in to get y. Okay? Yes? Yeah. Good. I mean, I see you're trying to factor it, but yeah, you saw there's an x there, and that would cancel it out. So, okay. Last calculator topic. Windows. Okay. So let's get familiar with the window option. If you press the window button, everybody has an X min, X max, X scale, Y min, Y max, Y scale. Okay? Can someone get the door? Thank you. The book will sometimes tell you what viewing rectangle to use. And this is kind of the notation it will look like. So you're going to see brackets that represent all the x values and then brackets that represent all the y values. And guess what? It's the exact same order that you see them in on your calculator. So if I wanted to tell somebody what viewing rectangle this is, how would I write the numbers down? Negative 10, 10, 1. Does that make sense? And then by negative 10, 10, 1. So that's what that translates to. Okay? So one thing you need to know how to do is if I give you an example of a graph and I say, change your window, you need to be able to do that, obviously. So let's do that real quick. If you take out your packets and open them up to the page that says graphs and the graphing calculator. Go ahead and take a look at 4A. Do you guys see where I'm at? On the page that says graphs and graphing calculator number 4. Okay? And type this into your y equals menu. And now here are the settings that they want you to use for the window. Okay? So let's see what happens. So right now, before I adjust the screen, it looks like this little squiggly graph. We'll talk more about those later. But they want us to change it. So let's change the window settings. Did you change the window already? That's why.
No. Oh, yeah,
So after you change your window settings, it should look something like this. Is everybody seeing that? Okay. If you look at A on your packet, this is the exact same thing as what's on there. So now you can kind of use your best judgment here and draw a sketch. That's actually one of the things we needed to do, so you can do that. Yes? What calculation? Oh, like you mean labeling it? So Yeah, you can definitely label it. So what was our x min? It was -2. X max was 2, right? Y min was -2. Y max was 2. And then now I'll just put some points that looks kind of like this. Okay. That's really all we need to do here. This is just getting you guys comfortable using your calculators to change some settings and look at things a little bit differently. Okay? Does this make sense? Okay, last thing we'll do today. And we're almost out of time, so I'll just kind of explain why I'm going to do the settings I'm going to do here in a minute. If you type this in on your graphing calculator to try to get a good picture, right now as is, without changing those settings on the window, it's not going to be a very good picture. I think I typed it in right. Okay. So right now, I don't see anything, actually, when I graph it. Okay? So now we have to use some common sense here. What does this 1200 represent? Y what? It's the y-intercept, yeah. If you plug in 0 for x, does everybody see that the y-intercept's 1200? So just from that, I'm going to go to the window and say, you know what? I can't even see 1200 because my max is 2. So I'm going to make it maybe 2000. And maybe let's do y min -2000. This is just a good, I'm just guessing here. We might have to mess around with these in a minute. Scale, let's say I'm counting by 500s. And now for the x min and x max, let's just try the old -10, 10, 1, just to see what that gives us. Not bad, but what shape should this be?
It's supposed to be
A loopy?
parabola.
It's a parabola. Usually for parabola, we want to see the high point, the intercepts and all that. So I'm going to go back to the window and then maybe make my x-axis longer. -50, 50. And then, actually, that's pretty good right there. Okay, so that's kind of how you, maybe a good scale would be, 25s. So that's kind of how you play with the settings there to get a good picture. All right. Good job, guys. I'll see you tomorrow. Actually, I may not see you tomorrow, but
Why?
I may not be here in the afternoon.
Why not?